speaker of today.
All right.
The amazing...
How am I sounding? Can you hear me? Luke.
Luke.
Hello, everyone. Good? Okay. All right. Hello, everybody. Lot of familiar faces. Nice to see you all again. Some new faces. If you don't know me, I'm Luke Bailey, design engineer here at Granola. Woo, yeah. My talk today is called Making Tooling. I originally wanted to call this Making Tools, but I couldn't get the typography balanced, so now it's Making Tooling. So my favorite talks always have a bit of a technical deep dive. So we're gonna start soft, and then I'm gonna try and get into some details in the time that we've got. My slides get progressively less visually interesting, so we're starting really heavy here. This is some of the work that I've done over, I realized, the last like 10 years. Some of these things are like 10 years old now. You'll notice there's a pattern. I really enjoy working with motion and interaction, user interface, and also WebGL. So you'll see there's a lot of WebGL projects where I'm tightly coupling those graphics programs into the traditional web stack. And there's one in particular here, True Staging, I did while I was at a studio called Unseen Studio. And I want to just look at that for a second, as I've got this huge folder on my computer. It's like 20 gigabytes, and I just screen record loads of stuff and show people. It's kind of just documenting my work. And a lot of them are like this, where it's the actual thing, and I'm kind of sending it to someone to ask them what they think. But this one, I was really pleased. I managed to find a process shot. So this is me debugging some material stuff. I think this is 2019. I can't remember what I was doing here. But the reason this is relevant to what I'm going to be talking about is because there's this thing down here and this thing up here. This is a little GUI. And for anybody who's ever worked with WebGL, you'll know figuring out what's going on is a pain in the ass. There's no right-click inspect. There's basically no way for you to really see what's going on unless you build your own tools so that you've got some visibility. This is a really simple one. I wish in this video I dragged the sliders, but essentially it's a GUI that plugs into the shader uniforms, which are like the props for the uniforms. And you drag them in real time, and you can debug what's going on visually, which is really useful. Otherwise, you have to render the shader in your brain or something like that, and so we don't do that. And so this is kind of, just hold this in your head. So at Granola, over the last 5 months that I've been here, we've been rebranding, rolling that out, and as part of that, there's a bunch of tools that we've had to implement to make things easier. Now, tools to me can mean loads of things. Sometimes a tool is as simple as a deprecation comment. Here's one that Tihan added to our legacy button recently, especially when you've got LLMs and stuff happening in CI. I think this is a tool now. Here we've got a cubic rule. Cubic runs on our CI and flags issues in PRs. This is a cubic rule called the Design System Police, and we're on the cases of the engineers, making sure they don't break our rules. And then we've also got another kind of text-based tool here, which is the Design System MD file. This is basically slop mitigation. With everybody, as we've kind of talked about this evening, with everybody contributing to a code base, it can easily, you can easily have drift. And so this is a little tool to try and make sure that LLMs don't do so much dumb stuff, basically. Another tool, another one by Tihan. This is a generate icons script that we implemented. We've got a huge library of icons, and this script grabs them, does a few things to them so that they work for us, and then adds them to Storybook in our code base. Another tool, this is an observability tool. We're migrating from a legacy system where we kind of had a design system that was mostly just a Tailwind file to something a bit more robust. And as we're migrating legacy components out and our new components in, we wanted to kind of see how that was happening over time. We weren't doing like a big, scary V2 trying to replace everything overnight. We're doing it slowly and gently, just so we don't break too much stuff at once. And so this gives us a bit of visibility into that. So another kind of set of tools there. This is a tool that I built inside of Storybook. It's called Diorama, and I need to change that name because I've said it a few times and people have thought I have diarrhea. I don't right now. And so this, this is just a really nice way for us to test out some interactions, prototype some UI in situ, especially stuff that exists based on app state. Right now we have a lot of UI components coupled to business logic and a bunch of other stuff, and prototyping in that environment is stressful. And so we have a nice sanitized, isolated environment here that we can test some stuff out, we can go through and see how things are flowing. So as part of our rebrand, we worked with Ragged Edge, amazing people, and this is one of our kind of leading visual styles. It's called illustrations. They're 3D objects that essentially clip what we call findings. The findings are the kind of paper textures and the collage type style. We love these. We love these, but they kind of presented a big problem for us, which is, how do we make these? What's the process? If we want something new, do we have to go back to an agency? Do we need to have a designer in-house who just makes these? And then I realized I can make a tool for this. And I'd actually done something similar at a startup I was at a few years ago called Contra. Again, same problem, really cool visual direction, but no way of us to like make them ad hoc as and when we need them. So I built this thing called the Contra Model Exporter. I think if you go to that link, you might still be able to access it. And you can see it generates PNGs of those outputs. And this was mostly used to add assets into decks and presentations. So kind of based on all of that and kind of the stuff that I knew there, I built this thing, which I'm calling Workbench. And this is where we can build out those 3D tools. I'm going to play this whole video. It's like 1:40. And you can see you can add in drag controls. We've got models where we can programmatically animate. You'll notice that it's an infinitely looping timeline. There's materials which we can tint and we can scale them, do a bit of art direction. So you can see here I'm making a nice green microphone. So as it goes, you'll see I'm going through our options. Here's some rotation. You can see you can turn on a bunch of axes and have it rotate in a way you probably don't want. There's also video textures as well as image textures. We can upload our own SVGs and extrude them to make models. So people are just, if you need something really quick, just add an SVG. We can also upload our own models as well. There's a scale option. And then this is in the export settings. And you can see might be hard to see, but there's a very thin line here. This represents the actual canvas. Everything outside of this line is not the actual canvas. It's really important that we had like a one-to-one with what you see here to what you end up rendering out. So it's a bit of like a WYSIWYG editor for our 3D assets. You can see here, I've exported a microphone. And here it is, the one that I made. This is the exact file that got rendered out. This is an MP4 on a white background, but we actually mostly make these as WebM videos. The Granola app is Electron, it runs Chromium, we know what browser version we're on, and it supports WebM, and that's awesome because it means we don't need light and dark mode backgrounds. It's just one asset that we can put in our app, and if it's on a dark background, that's fine. If it's on a light background, that's also fine. It doesn't break anything. And so the rest of my talk is going to kind of be breaking down kind of a high level how you make something like this, because I demoed this on Friday. Well, we have a meeting and a gathering here every Friday. We talk about what's going on in the company, and at the end we have demos. It's like the best part of the week. And when I presented the Workbench tool, people kind of lost their shit. They were like, how did you do that? And with the whole background that I've got in building stuff in WebGL, I realized there's just a whole bunch of stuff that feels quite intrinsic to the way that I work that a lot of people just didn't know about. And I don't think it's that hard anymore. I think a lot of people can be making tools like this. So let's have a look at how you do that. Before we do that, here's some of the places that it's starting to surface. Over there is a blog post, which was our Series C. I don't know if I can get that to play again. And we've got a little looping key there. This one in the middle, I'm particularly proud of because I had nothing to do with this. Pavan, who's already had a shout out today, got a 3D object, uploaded it, added his own textures, rendered it out, and put it in this prototype modal. And that makes me so happy because that's the whole point of this tool, is that the team can use it, render stuff out as they like. At a top level, there's really kind of 4 levels to how I think about making something like this. Starts with states, then you've got your interface layer, the WebGL layer, and then the render loop, which is also how we do the exporting. This is a bit more granular breakdown and exactly what we're doing in the tool. There's a Zustand store, it's our single source of truth. We actually don't get React to touch any of the WebGL. It goes up into the state, and then our WebGL layer then reads from that state. So we've got the React sidebar. That's basically all the UI. It's those bits on the right-hand side that I was dragging. There's a GSAP ticker, which in the web, when you're animating, there's a animation frame. That's the request animation frame loop. So we use the GSAP ticker because it allows us to get really close to that loop. 3JS, of course, is what we're using to render things. We've got some shaders, which we'll talk about. There's the GSAP timeline itself, which is, as you can see, we can pause and seek by phase and duration. It's deterministic. In a world of non-deterministic machines, it's nice to have some determinism sometimes. And that allows us to do this perfect loop. And then we have the export pipeline. This is a breakdown of the directory structure of this app. It's a Next app, runs in the browser entirely. There's no server-side rendering. It's got a few components. It's got one hook. There's 3 materials. Right now we basically only allow 3 materials to be added to an object. That number's probably going to go up. We've got the 3 directory, the ticker, export, FFmpeg, and shaders and store. So one of the key things that I mentioned is the looping. Sorry, frame emotion, but GSAP wins here. I love frame emotion. It's great for doing a lot of DOM transitions, animating stuff with CSS. It's great, but it doesn't give us access to that seekable deterministic timeline. It's really hard in Framer to say, give me frame 47 of 120. Doesn't quite give you that out of the box. It's all kind of hidden away, which is why it's so nice and easy for a lot of people to use. But for this, we needed a bit more control. So I used GSAP. I'm so sorry about this next slide. It's ChatGPT generated this for me. Design engineering at its best. So you can see basically what I was explaining. It's really hard to do this. GSAP, because it's got this ticker, which is essentially a proxy for the request animation frame, means that we can do a lot more. So this is the kind of core logic of how we get that perfect loop. There's a loop phase where we take the duration of the video that you want, and we know we only ever want to do a 360 loop, right? We don't want to loop 7 times and create a 4 GB video when we could loop once perfectly and have something that's coming in closer to a couple 100 kilobytes. So we get that time modulo by duration. So if it was 5 seconds, we'd count up to 5, and then we'd loop back down to 0, and we count back up to 5 again. And here you can see if we do have a rotate Y, then we use that loop phase plus this 2a, which is basically a Greek symbol, which is 2 pi, which is 1 full 360 rotation. And so that's how we make sure everything stays in sync, and loops. This is basically all of the magic that is in this project is in the shader. On the left, you've got a more traditional shader where we're projecting our textures onto the surface. This shading is called UV shading, just to give you an idea of what's happening. Tiny down here you can see when we sample this texture 2D, the map is the image, and then the VUV is a vector of our UV coordinates. Don't worry if that doesn't make sense. And then over here, we're doing something different where we're actually just projecting the screen space. Normally you want your textures to be on the object, but here our object acts more like a mask to clip the texture beneath. Again, we've got another ChatGPT slide coming up. This is the render pipeline. It looks really hectic, but I'm going to hopefully make it feel a bit more simple. So there is two ways that we render things. There's the preview. That's our real-time render. Every frame, hopefully at 60 frames a second, it's rendering, and that's what you see when you're in the tool. The second way that we render is not real-time, and that's for our export. You can see here, repaints continuously on each tick, may drop frames if GPU is busy. So if you're on a lower-end computer and you're trying to render a 4K video in real time, you're going to drop frames. And we want really nice motion at whatever frame rate you specify. And so that's where we jump off into FFmpeg WASM. So does anyone know what WASM is? A few of us? Nice. OK, cool. So this is basically WebAssembly, and it allows us to run code in the browser, but off the main thread. So you're able to do stuff like create a virtual file system. And here, we don't need to render in real time. We can just render our image, our frame. We can save that as a PNG. We can put it into this file system. And then using FFmpeg, we run a command. And then that outputs our videos. It's that simple. So it looks crazy here, but actually, when you break it down, if you know that these are the components that you need, slap them into Claude, slap them into Cursor, and you'd be able to export 4K video at 120 frames a second, even if you're on a screen that is smaller than 4K. And that's because we create an off-screen renderer, an off-screen canvas. If it was on screen, firstly, you'd see the canvas when you're exporting. It would be there on screen. And also, it's much easier to render something that's larger than your screen in that scenario. I've been talking for so long, my laptop went to sleep. So this is the tool. Again, just as a reminder. And this is the kind of steps that it takes to make it. I think that tools are, it's really natural for us to make tools. That's why I had the little arrowhead on the first slide. I think that making tools for yourself is so easy now that even something as complicated as this was made in a day, I think max. But all the other tools, whether it's documentation, something like the diorama that we've got in Storybook, Storybook itself, these are all great tools. And I think as design engineers, when it comes to solving the problems that we're confronted with, building tools can be one of the funnest things to solve those problems. So my advice to everybody is go forth, make some tools. They don't have to be WebGL tools. They probably should be, if you ask me. But ultimately, I would just all encourage you to go make an interactive tool, have some fun, see what you can do, and share them with everybody. Thank you. That was a quick one. 3 questions.
How did the agency do it before this tool existed?
So they were building these out in 3D tools. So they have a 3D artist in-house who was making those in, I think, Cinema 4D, maybe it was Blender, rendering them out. So the stuff that we have in the brand guidelines, if I go back up, all of this stuff that we have in the brand guidelines was all made in Cinema 4D, yeah. Yep.
There's like an XKCD thing about automation, and it shows how long you spend automating something and how long it'll take to, like, for that to actually pay off, like, depending on how long the task actually takes. Does something like that come into consideration at all, or is it more of like we want to be able to do this in-house, and how might we do that?
Yeah, totally. I think one of the whole reasons behind wanting to build an in-house tool was to speed us up. It wasn't because we thought it's going to take us ages, it's going to slow us down. It's made the team able to make these things themselves. And so yeah, so yeah, we were thinking about time, and this is to save us some time. God, okay, you over here.
How do you encourage people to adopt like the tools internally?
Yes, great question. So we have our Friday demos. I showed everybody this tool. And everybody with this one really, really wanted to use it, so I didn't have a problem there. We use a Chrome plugin. I can't remember the name of it, but it basically gives us a bunch of shared bookmarks. We all install it and we log into it. And so I can just go to my browser and it's go/, and then we'll have a key for whatever page we're going to. And this is go/3D. So it's really easy for people to find it. We'll post up in Slack and explain stuff. And then there's also just a bit of like word and mouth, and like I will go and grab designers and engineers by their collar and I'll say, you have to use the tool, please use the tool. So that also does come into play.
How do you go about maintaining all these tools? Because I see you shipping a lot of things, but then is there a regular cycle of looking back at the original ones?
Yeah, I think it's a pretty lean approach. We kind of have built this tool to fit our first needs, and that was just WebM videos. And then I realized I didn't even build a way to create a simple like snapshot PNG, so then we added that. Then we realized we wanted some of these to live on our website, and we then couldn't just have WebM videos, because then it was going to be on the real web where people use browsers like Safari, and WebM isn't supported. And so then we added the ability to add backgrounds, colors. Pavan hit me up and he was like, I need to upload this model. And I was like, give me 10 minutes. It took more like 2 hours, but then we got model uploads in. So yeah, I think when it comes to maintaining this, because a few people are using it, I hear where they're having struggles, and then kind of when I can go in and try and fix it for them and add some stuff. Go on, one more.
So it was cool that with Wasm you could have this virtual file system. What are other cool things that Wasm can do that we would or not?
Well, it's assembly in the web, so you can kind of do anything. You can, with WebAssembly, you could run another browser in your browser that runs GIMP, the editor, and then because it's assembly, that's a hard question. Kind of whatever you can think of, really. Yeah, I wouldn't be able to do all those things personally, but yeah, anything you can compile to assembly, then you can run.
Cool. All right. Thank you, Luke.